Hey, this is Ryan Linfield. I'm stopping by today to show you a quick crash course on class maps, policy maps, and service policies. Collectively, these three utilities are together known as Modular Policy Framework, or MPF. So let's take a look at how this all starts. Effectively, let's go ahead and take our circle here. This is going to represent our ASA. Our ASA is going to have an outside interface, that's what we've got to the right, and an inside interface, which is what we have to the left. I'm going to go ahead and label this outside, and as you could have guessed, we've got the inside over here. Whenever I want to operate on particular traffic flows, this is typically going to be done through the use of Modular Policy Framework, or MPF. As most of you are already aware, we can use access control list to prevent or permit traffic to flow through the ASA. But what if we want to allow it to flow through the ASA, we just want to operate on it a little bit? We'll take a look at some of the mechanisms that we can use for operation as we go through this today. But the first thing we have to do is identify our existing traffic, and then we're going to have to take an action upon it. So step one is to identify, step two is to perform an action. For identifying traffic flows, we're going to use our familiar friend, the access control list. Whenever we use ACLs, we simply define a traffic flow. I can say, hey firewall, when you see traffic sourced from 1.1.1.1, destined for 2.2.2.2, and see how I just paused there. The access list itself just identifies a traffic flow. It doesn't actually say what you want to do with that traffic. If we apply the access list to the inside or outside interface, what's going to happen there is that we're going to permit or deny the traffic through the interface. If we wanted to get a little bit fancier and maybe redirect that traffic to an IPS module or perform specific types of application inspection on it, so we can do a little bit more granular filtering. If we wanted to perform QoS mechanisms on it, we're going to have to go a little bit further, and that's what brings us into class maps, policy maps, and the service policy. So we're going to take that access list that we previously described, which does nothing until you apply it somewhere, and we're going to put the ACL into a class map. Now a class map is really just defining what I call the if condition. If you see packets that look like this, well, then take some type of action. So the same way that an ACL essentially does nothing at all until we apply it to an interface, the class map is very, very similar. A class map does nothing but define some type of traffic that we want to match. We perform the action within something called a policy map. So the policy map will get a name, and a lot of times I'll just name it something like outside. It's going to be the name of our outside interface there. So I'm going to use the color red, I'm going to use a little circle and say this is where I'm putting my policy map. So it's going to go on that outside interface. I'll also associate a direction like inbound or outbound, and then I'll take some type of action on this traffic flow. So let's take a look with an ASDM. ASDM, here we go. And we'll go ahead and kick this guy off in demo mode. If you haven't used this before, it's free from Cisco's website, provided that you have a CCO login, and you can bring up ASDM so that you can test things out, or in my case demonstrate them, without actually having an ASA available. So the first thing I'm going to do is drop down to preferences here, and I'm going to set the communications option for previewing commands before I can send them to the device. You're going to like this because I'm going to show you first how to configure class maps, policy maps, and service policies from ASDM, and then you'll be able to follow along from the CLI what it would actually take to perform the same steps. So we would go to configuration, we would drop under firewall, and we have this option here for service policy rules. I want to create a service policy, which is really just the command that we use to put a policy map on the interface. I want to put a policy map on my outside interface, and you'll see that we use a service policy to do this. So I'm going to select add, I'm going to go to my interfaces, I'll select outside, and the name here, outside policy. Not the most innovative name, but you can also see with a name like this, we don't even need to bother with the description. You can read the name and you know that this is a policy that's going to be applied to the outside interface. So what do we actually want to do within this policy map? Well, I want to have a class map that, once again, I'll put in the description, this is our if condition. So this is what we're going to match upon. I can match default inspection traffic, which just basically says look at any port number for any protocol that the ASA knows how to inspect. For our purposes today, this is a little too broad. We can use access lists, we can use VPN tunnel groups, I can use port numbers, so if I don't really need to think about the source and destination IP address, and maybe I want to match on anything that's port 80 or anything that's port 445, I could use this. I can use RTP range to match real-time transport protocol. I can match diff serve code points or IP precedence. These are two different values which could be found in the type of service field of your IP header, or optionally I could just match any traffic. These are our different traffic match criterias. To be honest, the one that I use the most is going to be the access control list. So this walks us right through it. They go, what is your source? And just for example, I'm going to say any packet sourced from 4.2.2.1. That's my lucky IP address. It's a DNS server you might be familiar with. And I said if anything is coming from 4.2.2.1 and it's destined for, and we'll look through different objects here that the ASA knows about, maybe I've got this particular network, 10.1.100.0. So I'll say anything sourced from that particular host to 10.1.1.0 that, and I can go in here and pick a service like TCP/80, which would be HTTP. So we can filter for that. Here we go. And optionally, you can go into these options and I can reference a time range. With the time range, it'll make this rule only active during particular parts of the day or days of the week. So I could say maybe work hours from like 9 to 5, maybe after work hours from 5 p.m. to 9 a.m. the next morning. I could also specify the source service if I know what that's going to be. So for now, let's just say anything sourced from 4221 with a /32 mask going to 10.1.100.0 that's using HTTP services. Now, technically, that is going to be, I believe, an object group. So maybe if I can just be a little bit more specific to make sure that I just get port 80. Let's take a look here. Okay, so looking at HTTP services, this is going to contain HTTP and HTTPS. So for this quick example, which should be a quick example, I'm just going to go ahead and use those. So we're going to match on 80 and 443. And when we go and see the CLI preview after this, we'll be able to verify that. So at this point, we said on the outside interface, I want to look at any packets going from 4221 to our interesting network on port 80 or port 443. The next option is, what do we actually want to do with it? So we could do things like just check this box to be able to perform HTTP inspection. I could adjust my maximum number of connections here. I could adjust idle timeouts. I could disable TCP sequence number randomization. I could allow the ASA to decrement the time to live. I can just operate on that traffic. If I had an IPS module, I'd have an IPS tab above that says redirect this traffic to the IPS. I could enable priority queuing for this flow to make sure that it's expedited. I could enable input policing and say if anything is coming into my web server, which would have to be like an HTTP upload, I could limit that to 1 megabit per second. So long as the transfer conforms to this rule, the traffic will be transmitted. If it exceeds that rate, it would be dropped. So at this point, okay, it doesn't want to let me do NetFlow. So they say you have to do a global policy for NetFlow. That's fine. I'm just going to say for that particular flow, I want to enable policing and rate limit to 1 megabit per second. At this point, I can hit finish, and it's not until I hit apply that it's actually going to generate the CLI commands for me. And this is where we can see the layering of the access list, the class map, the policy map, and the service policy. So just to go back and talk about what we've done here, let me grab a pen. We defined an ACL, which is our interesting traffic. That ACL is going to be placed inside of a class map. Once it's inside of the class map, we can put the class map inside of the policy map here. And the next thing we would do is take an action upon it. Our action in this example is going to be rate limiting. So if our policy map was called outside, our third and final step would be use the service policy command to put the outside policy on the outside interface. So to step through these one last time, identify the traffic with an ACL. The ACL goes into a class map. At that point, we only have an if condition. To get an action out of this, we create a policy map. Within the policy map, reference our class map, associate an action, and then finally, in the third step, we use, and I'll just type this out, we're going to use the service policy command to put that class map within the policy map on the interface. So there's going to be quite a bit of nesting. Let's go back into ASDM and take a look. From the bottom up, here's the service policy command. It puts the policy called outside policy on the interface that's called outside. That was step 3. Step 2 was our policy map called outside policy. Notice the same name here and here. Outside policy is our policy that goes on the outside interface. What does it actually do? Well, it references a traffic class called outside class. What is that? Well, if we look above, we've got this class map called outside class that references an ACL. Here's the name of our ACL. And if we look above, let me just drag this out a little bit further, we see we've got an access list here that permits TCP traffic from 4221 to the 10.1.100 subnet. And specifically, it's looking for an object group called HTTP services. That HTTP services was predefined within ASDM, and it matches upon port 80 and port 443. If I wanted to just match port 80 from a CLI perspective, instead of referencing an object group, this would just say equal 80 or equal HTTP. So this is our access list. The access list, called outside MPC, is placed within our class map. We see that here. And you can tell from the indexing on our text that this is indented a little bit, and we can see that this is part of the class map called outside class. That class map goes inside of the policy map where we take our action. That's going to be policing. And then finally, our policy map goes onto the interface. So when I hit send, that's going to go ahead and be applied, and we can see that here's our outside policy. Now if I check it, it'll be enabled, and that inactive keyword that was at the end of the ACL previously is now there. I'll take this one step further and I'm going to edit it, and I'm going to create another traffic class. Let's add an entry here to my outside policy. And I'm going to create a new traffic class, and I'll say I want to match anything with a differentiated services code point, and I'm going to say a code point of 46. This is what your Cisco voice phone is typically going to mark all of the audio packets as. So now I'm creating an if condition that says, hey firewall, anytime you see a packet that's marked with the number 46, which means expedited forwarding, and now he goes, yeah, what action do you want me to take? I go, well, I just want you to enable priority for this flow. What that means is steer that packet into the VIP line. I've got 2 lines. Let me go back to my diagram here. On that outside interface, I have 2 lines, or 2 queues, for packets to wait when they want to leave the interface. I'm going to make my red one up top that's real important, and I'm going to make a yellow queue below. So these 2 queues have got names. The top queue is called the priority queue, also known as your low latency queue, or LLQ. Your bottom queue is known as best effort queue, or BEQ. This is where all packets go by default. The priority queue, or your low latency queue, is where we're now going to serve any packets that have a differentiated services code point of 46. We say anytime a packet comes in with that marking, send it into this queue. You have a NIC driver, which I always think of as just a little man that sits on the wire here, and he reaches into each one of these queues, pulls packets out, puts them on the wire, and sends them out. The purpose of this priority queue, if you've ever seen a nightclub or been to a nightclub before, you've seen that VIP line. This is our VIP line. And I think of it as the VIP line because it's actually a voice over IP line. This is where all of our really important traffic goes. The door guy that's waiting there to let packets out the door always services the VIP line, or in our case, the VoIP line first. So by just checking that enable priority for this flow, this is going to modify our policy map and add an extra entry. Let's go ahead and apply and take a look at this. Now it says priority queue outside. What that first command does is generate this second queue that I drew in red there. When we say class map outside class 1, this is just a new class map. It goes in there in addition to our other class map, which was matching an access list. This one just matches the diff-serve code point of 46. Our class map gets nested inside the policy map, and then the policy map says, hey, firewall, when you see anything that matches outside class 1, and he goes, oh, you mean DSCP 46? We say yes, steer that traffic into the priority queue. Cool. And at that point, we have two different policies. One that uses an access list to match upon traffic from one source to another destination. And then we have another flow here that matches anything based on the differentiated services code point. And then you see here that here's our action. So some things are going to be rate limited, while others are prioritized. So these are the types of things we can do with class maps and policy maps. We can go above and beyond what you'd traditionally use an ACL for, which is just permitting or denying traffic through the interface. I hope you found this useful, and I would, if you have the opportunity, mess around with this a little bit in the lab. Try rate limiting some of your own traffic inbound, and when you do that, pay attention to the source port. One of the things that I commonly challenge my students to do in class is I say rate limit your HTTP download to 1 megabit per second. So they'll go to speedtest.net, they'll do a download, they'll see 45 megabits per second. And I'll say, okay, rate limit that. And the way that you would do it, I'll show you real quick, and then we'll wrap up the video. I'm going to do one more demo here. We would say add a service policy rule. We're going to add it to the outside policy. I'm going to use an access list because I can't use a destination port. I'm going to show you why. What I want to do here is match traffic coming from a web server. Well, we know if it's coming from the web server, it'll be sourced from port 80, destined to who knows what port, some dynamic port. Remember, the HTTP request goes out. This is just a GET with some resource name. This is super tiny as far as bandwidth is concerned. It's this response that we're worried about. This is what could be some 4 gigabyte ISO that's going to kill all of our bandwidth unless we prevent it by rate limiting. So the way that I would achieve that is by going in here and saying, hey, firewall, anytime you see traffic sourced from anywhere, and it's destined for, and I'm going to be real sloppy and put anywhere. If I wanted to be a little bit more specific, I might perform rate limiting based on a particular subnet. Now, what I'm going to do here is say for the service, I want to say, let's see if I can just find regular old TCP here. And what I'm going to do here under source service is I want to say TCP port 80. So here's our TCP 80 here. I'll select the service, I'll hit OK, and you see here this is our service. So anytime you see packets sourced from anywhere, destined from anywhere, that are sourced from 80. A lot of people mess this up and they put the destination port of 80 here. And that will only rate limit your HTTP request, not the replies. So I'm going to do next. I'm going to say QoS. I'll enable policing. It's going to be input policing. Once again, 1 megabit per second. Make sure you get all your zeros there. An extra 0 is going to make a big difference. I'll hit finish. I'll hit apply. Once again, this is our final demo, but I hope that this makes sense to you now. We have an access list called outside MPC1. The access list is placed within a class map. That class map, called outside class 2, gets nested inside of our policy map. This has been the same policy map the whole time. It's called outside policy, but now there's 3 different classes that are listed. You don't see it here because these are just our changes, but if this were a real firewall that I could SSH into, I would do a show running config and I would see multiple entries here. For my policy map called outside policy, we see that we're matching this class and we're just doing some rate limiting. I'm going to go ahead and hit send, and this might be what I call the live demo fail, but I'm going to see if this will support a show run. Haven't actually tried it before. So show run, this would work on a real firewall, but I want to see if it'll work in the simulator. Nope. No such luck. If this was a real ASA, what it would have done was showed me my entire configuration, and what we would see is there's a single policy map called outside policy. It references 3 class maps. Those class maps are called outside class 1, and outside class 2. I could have been more creative with the names. This is just what the ASA defaulted to, but we're matching different traffic flows in each of these. Some traffic flow that's web, some a traffic flow that's expedited forwarding, and you see here we can take various actions. One of the most common actions that I use is redirecting traffic into an IPS. We don't see that capability here because this simulator is just ASTM running in demo mode. It doesn't have an IPS module. Anyhow, I hope you found that useful. That was about 20 minutes, but I hope class maps and policy maps in the service policy command make a bit more sense for you now. Thanks for watching.